you have done your homework and watched the video for lesson 7.2, which was on similar figures. Today we're going over similar triangles, which is just kind of extending our rules about similar figures and making them a little more specific just for triangles. Now we have three different similarity postulates. They're kind of like the three congruency postulates that we learned from triangles earlier in the year. We have the angle-angle similarity that says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. We have side-side-side, which just basically says if the corresponding sides of the triangles are proportional, all three of them, then the triangles are similar. And then we have the side-angle side that says if the measure of two sides of a triangle are proportional to the corresponding sides of another triangle, and the included angles, okay, included means the angle in between the two sides, are congruent, then the triangles are similar. Well, let's take a look at an example here. Alright, so we have these two triangles up here, triangle 1 and triangle 2, and we can see that their sides, we have, if we set up a proportion, their corresponding sides, we have 14 and 7, and that should equal 14 over 7, which should also equal 12 over 6. And we know that if we reduce them all, we'd get the ratio of 2 to 1. All of these are equal if we do our cross multiplication here. 14 times 6 and 7 times 12, then we should get the same number. 14 times 6 is 84, and 7 times 12 is 84. So they are proportional, which makes this the side-side-side similarity. Okay? Alright, now looking at the two triangles below it, I have a 90-degree angle and a 40-degree angle. And on this triangle I have a 90-degree angle and a 40-degree angle. These two are similar because of the angle-angle similarity. Now, why can we say that these are perfectly similar? Well, because if I know that this is 90 and this is 40, if I take 180 and subtract 90 and 40, I'm left with 50. Same thing over here. And so I have three angles that are all congruent, which means the figures are similar. Oh, blank page, sorry about that. And finally, I have these two triangles here. I have corresponding sides. I'm going to set this up as 12 over 24. They have to equal the other corresponding sides, 10 over 20. And if I multiply those two, they have to equal those two multiplied. 10 times 24 has to equal 12 times 20. And guess what they do? They both equal 240. Okay, so the sides are proportional, but it also has to have the angle included, which means the angle between those two sides. And guess what? On both of these, it's the same. So this is called the side-angle-side similarity. And y'all know this. This is easy stuff. Okay, here are two triangles, and notice that these arrows here are placed here. Those arrows mean that those two lines are parallel. Okay? And when we have parallel lines, if you want to extend them out a little, just so you can see, this line here, this side here, is a transversal, which means that this angle and this angle are congruent because they are corresponding angles. Alright, so now we have to take the triangles. We've got this little one here. Okay, that's our first triangle with sides 9 and 12. And we don't even have to know what the angle is. We just know that they're proportional. So on my small triangle, I have sides 9 and 12. And I'm going to set this up as a proportion to see if they're equal. And then I've got my large triangle, and I want to kind of do this separately to show you. We're talking about this whole thing here, not just that little part over here, but the whole thing. Alright, so this is my large triangle. Let me switch back to black. My large triangle. And my side that corresponds with 9 is going to be my other parallel side, which is 12. And my side that corresponds with 12, this outer shell here, is going to be this whole thing. So I have to add them up. 12 plus 4 is 16. Okay, are they equal? 12 times 12 is 144. And 9 times 16. 9 times 16 is also 144. So I have proportional sides. 1, 2, 1, 2, and I have the angle in between those sides is congruent to each other. So this is another example of side, angle, side. Now you may be thinking, okay, this is great and all, but how do I use this in real life? Oh, went a little bit too far. Okay. Have you ever wanted to measure something that's really, really tall, but you know that if you sit there with a ruler, you're never going to get it measured? For example, a tree. Well, when we have a shadow of the tree and of ourselves, or something we know the height of, we can figure out the height of the tree by using similar triangles. Okay? And if you can't see the triangle here, we've got this triangle. And then we've got this triangle here. Okay, that goes all the way up to the height. Oh, sorry, that should be the length of the shadow. I kind of drew my triangle wrong. Alright, this angle up here is going to be equal for both of them because the angle of the sun is going to be equal at that time. Now, we also have this angle being 90 degrees. Okay, so we have the angle postulate because we've got the angle from the sun and the 90 degrees, which is the height of the object, the height of the man and the height of the tree. So all we have to do to find the missing piece, we know that the triangles are similar, we just have to set up the proportion of the sides. I'm going to do the height over the shadow. And now I'm going to start with the height of the man, which is 5 feet, and his shadow is 15 feet. And that's going to equal the height of the tree, which I don't know, and the shadow of the tree, which is 108 feet. Okay, I'm going to cross multiply because that's what we do to solve proportions. 108 times 5 is 540. That equals 15x. I'm going to divide by 15, divide by 15, and I get 36 equals x. So this tree is 36 feet tall. Okay? Pretty cool, right? We're going to go try and measure out a tree in class. Now, here's your example problem. Are these triangles similar? How do you know? Are they? If they're not, how do you know that they're not? If they are, how do you know that they are? Well, that has been our lesson today. Make sure that you come to class prepared to learn.